Hi, I'm going to show you how to take exported data from MS Style and format it for MetaboAnalyst for an initial set of processing that MetaboAnalyst will do, and there will be a future video on some other stuff. This video assumes that the data set you're dealing with has less than 5,000 features. If it has more than 5,000 ion features, then we will add some extra steps. But there are two ways you can do this. You can just drag the sample data into Excel and do it manually here, which is a bit time consuming. And if the larger your data set is, the more time it's going to take. The easier way to do it, in my opinion, is to use Power Query, which is a formatting tool that looks at a snapshot of the data, usually the top 200,000 rows, and then you tell it what to do based on those rows, and then it will do it to your entire data set, say if you had 50,000 lines or so. And it's got a lot of, it's built into Excel, and it behaves very similarly to Excel, and ultimately it will dump into Excel in the end, so if you need to do other stuff, you can do it. And so what you do is you go up here to this data tab. Sorry, let me maximize this. Data tab, we're going to grab it from text or CSV. Sometimes in an older version of Excel, you might have to click this get data one over here. Data tab on mine's on my desktop. It's just labeled for some testing I was doing a while back. And so we'll see the .msp file format. The way it comes up is the top four rows are blank, and then it has columns of data for each ion feature or a line data, piece of data. And so it asks you it recognizes some stuff. You can tell it things, but for the most part, it recognizes this well. And then you can either load it directly into Excel as a table or transform it. We would like to transform it, which will take us into Power Query. So we are now in Power Query, which happened to pop up on my other screen, so I will drag it over. And we are previewing the data. As you can see over here, it tells you 42 columns and greater than 1,000 rows, and we're profiling the top 1,000. And so there's an order of operations we want to do. If we do them, we can and mess it up, we can take them back, which is why Power Query is very nice. And so right now, the first thing we'd like to do is delete the first four rows. So we're on this Home tab. We go to remove rows, we go to remove top rows, and then we hit 4. The other good thing about Power Query is if you do this regularly, these steps will generally all be the same, and so you can be used to it, and there's a way to make everything feed through this in the same way every time, but it's a little beyond what we're discussing here. So just to show you, say I deleted the top 5 rows or the top 3 and I need to take that back, you can come over here, hit this X, and now we reverse what we just did. So that's very nice. Say you mess something up 4 rows up, you can delete everything, go back and rework it. And once you dump this in Excel, you can actually come back here, which is the other nice part. So again, we want to delete the top 4 rows, hit 4 here. And now we want to promote this first row to headers because then it will identify all this stuff for us as the different types of data it is. So use first row as headers. It'll also make the following step easier, which is we don't want all this data. You have alignment ID, retention time, MRZ, and a ton of information. And then eventually you have blank samples, pooled samples, etc. And so for this, we really just want this average RT row, this average MZ row, and the sample data, assuming you've done blank subtraction in MS Style. And so we will go to choose columns because there are a ton of columns, again 42, and we only want, in this case, 5 because I only have 3 samples in this set. But say we want 2 columns, average RT and average MZ, and then however many sample columns you have. We're going to unselect this, and we're going to select the ones we do want, which is average RT, average MZ, and we're going to just select the 3 example samples I have here. But if you had 15 samples, you'd select them all. And then everything else is not necessary at the moment. So hit OK, and now we're down to 5 columns as noted here. And so we tend to use the concatenated M/Z and retention time as a label, and so we're going to go ahead and do that. In order to do it in the way we want, I'm going to rearrange and drag MZ over to the front. They have switched places. We're going to go to this transform tab up here, Go here, hit control on each header. You go to merge columns. It asks you what separator you want. You can use one of these, or I'm just going to use a custom underscore. You can tell it what you want. We can say MZRT at just a label the column. You can manually do that if you want by clicking on it, but it's just easier to do it there. And we have our concatenated columns. And now we have our 3 sample columns with area data for each ion feature. And so at this point, we're happy with it, and we want to go into Excel and put the finishing touches on it before we need to save it. So we go home, we go to close and load. It will directly load it to a worksheet and label it whatever our name was. We could have changed the name in there, but we didn't. And then we can delete this, but we don't have to. At this point, because you might want to go back and work some stuff back, you may and probably want to save this as just an Excel file initially. So I'm going to go to my desktop and find out, and we're just going to say MA5 process, and it'll say Excel file. And you can obviously name it whatever. I mean, it would save as an Excel file anyway. So in order to do the finishing touches for MetaboAnalyst, we essentially need to add a couple of labels. So this MZRT is just going to be called sample because it's reflecting this row with the sample names up here, not necessarily the data under it in the column. The second one, we're going to call this label, and this represents groups in the row. And so if this were group 1, group 2, or group A, B, and C, it could be 1, 2, or 3, whatever you want. This label reflects this, or this label title reflects the information in these cells in this row. And then you have your ion feature data and area for each sample in the following rows. And so at this point, it is good to go, and we would go File, Save As, a .cs. Oops, well, it's actually where we wanted to be, but we're going to go File, Save As, .csv, or here, and then we're just going to call it MA process aligned for data, and something to that effect. But now we have a CSV, save it as, there we go. And so this is if you have less than 5,000 ion features. If you had greater than 5,000 ion features, we would add some extra steps involving averages of the signal from each of the samples, and I will show you that in a future video.